Okay, good morning, ladies and Will.
Hey, Mr. G, can I borrow that calculator, please? Haley stole your
Now, we're not going to be using calculators at the beginning of class, maybe toward the end of class, but you see that these are problems without a calculator.
Can I also take it with me because I need it for
Okay.
my physics test
That's what you're saying.
for the next 2 days? But I'll bring it back after, like I always do.
You lost your calculator?
No, it's just not charged.
Well, bring it. Bring it, we'll charge it in here. It's a newer, updated calculator compared to the one that you're borrowing now. Okay, so anyway, here we have,
It'll get charged eventually.
yeah. Okay, so what this is an equation. So it's saying the sine of what? So sine of what angle or unknown is equal to 1/2. So that's what it's asking. That's your unknown. So what is the angle whose sine equals 1/2?
So can you do that second sign thing?
You can do it, but this is without a calculator, right? Yeah.
Right.
So put your calculator aside. Now, all these in 41 through 48, without a calculator and their acute angles, which angles do we have to be talking about then?
Lower than 90.
Lower than 90s. And which particular angles? 0, 30, 45, 60, 90. Right?
Lower than 90.
But yeah, it would be between 30, it would be 30, 45, 60. So they're all going to be 30, 45, 60, right? Because they're the only ones you could really be without a calculator that are acute, that you're expected to be able to do without a calculator, right? So, anyway, so which angle has a sine of 1/2? Now this goes back to our unit circle trigonometry song. 0, 1/2, and square root of 2 over 2, that's what I'm telling you. Square root of 3 over 2 and 1. 0, 1/2, and square root of 2.
30.
It's 30, yeah, 30, right? So 30 degrees. So this is 30 degrees, so theta is 30 degrees. And in radians, that's going to be what? 0 pi over 6, right? Pi over 6 radians. So that's going to be our answer for problem number 41. All right? Are we ready to choose people for problem 42? Yes?
It feels really good in here, by the way.
It feels good in here?
Yeah, it's like really toasty.
Well, the heater just came on. It said it's 70, but it'll come on periodically to...
It's kind of pointed at me, Carmen. It feels really good.
Yeah. Okay, so I want to go ahead and call somebody for number 42. And we don't have Angel here today. So I'm gonna get Angel out of the equation for today. Okay, shuffle. It'll be Hannah or Emma, which was it? It'll be Hannah. Emma. That was right on the line. Okay, Emma.
So you throw the degree, you get the 60?
It's okay, 60 degrees, okay. Yeah, it's gonna be how many radians? I'll tell you, pi over 3 radians. All right?
Can you do the song again?
Okay, this is the sign. 0, 1/2. Let's do it. 0, 1/2, and square root of 2 over 2. That's what I'm telling you. Square root of 3 over 2 and 1. The sine is the height at any radian. Square root of 3, that's square root of 3, right? Square root of 3 over 2 and 1. The sine is the height at any radian. Pi over 3. 0, pi over 6 and 1, next one, pi over 3, pi over 2. It's all the song, right? Okay, what I want you to do is, we'll go to 43.
Wait, can you do the pi over ones again?
Okay,
I'm writing it down.
well, they're on your lyrics I gave you for the song.
You did not.
Didn't I, yeah, they're right on the song I gave you. You don't have that? You threw it away?
I didn't throw it away, it's in my car.
Oh, it's in your car, okay. So the sign 0, 1 half and square root of 2 over 2, that's what I'm telling you. Square root of 3 over 2 and 1. The sign is hide any radian.
The other one. I
Okay,
had pi over 3 and pi over 2 at the end.
okay, then the cosine, the x's are 1 square root of 3 over 2, horizontal, they must be square root of 2 over 2, and next are 1 half and 0, the state dx, that's cosine. Secret even cosine, but that's coming. Okay, this one here is not as easy, right? Yeah, you gotta get it flipped, right? And these are always gonna be special right triangles. So should I spin on this one?
Yeah, we can try.
Okay, I'll spin on this, we'll try it, see who has this one. Hannah or Carmen? It's gonna be Carmen. Carmen, this thing just loves you. All right, Carmen, what do we got here? What I'm gonna do here is I'm gonna hand out something else for this class. And now's probably a good time.
Thank you. Stupid question. I need that.
Now what I want you to do is I want you to work with this thing without using it when you can, and refer to it sort of as a last resort. Now look here, I think I'm one short here. I can go look for one.
So Mr. G, I'm trying to fill out this thing.
You're trying to fill out what?
So I am stuck on, so I have the 2 over 2, square root 2 over 2, square root 3 over 2.
Yes.
But I need the one that goes,
0,
and then
1
something.
half, and square root 2.
Is Tanner on here or not? Just not saying it?
0, 1 half. Okay.
Tangent, is it on here or I'm just not saying it? Or is it not on here?
Mr. G. It's not.
Thank you.
Okay, so you don't see cotangent on here, Carmen? There's no tangent or right here. So let's talk about what tangent is. Okay, tangent is what over what?
Opposite over adjacent?
Opposite over adjacent. Very good. Or rise over run. Or what over what that's on your unit circle. Sine over cosine, right? So what this does, there's something I haven't shown you until now that is helpful with the unit circle. It's called the hand trick. You've seen me use the hand, right, to get 0, 1 half and square, okay, or 0 pi over 6, pi over 2, right, or all the way to z. But what happens is, when you have an angle that you're looking for, in this case, which angles could this possibly be? If you look at 30, 45, and 60 degree angles, which are the angles that have anything to do with square root of 3? You're 60 and you're 30, right? So you're 60, you're 30. So what happens is, the way it works out is this, that you have square root of, your tangent is going to be square root of fingers below over square root of fingers above. So here we have, your tangent's going to be square root of, what's square root of 1? 1. What's square root of 3? Square root of 3. So the tangent is going to be 1 over square root of 3. But obviously this is not the tangent, but the cotangent is reciprocal, right? So if we go to cotangent, it's going to be, what's square root of 1? 1 over square root of 3. So what is your answer going to be for this? 60 degrees. Okay? So Carmen, are you saying to yourself, shoot me now?
Yes.
Okay, here, let me show you. I'm going to back it up and show you in the, Carmen's got unfortunately stuck with it. That's, Carmen, it's just bad luck.
Not just Carmen.
It's all of us, not just Carmen.
So Carmen, we have to start giving you a different name than Carmen. We have to call you Karma. As in bad luck. All right. You ever heard that before? So here, Carmen and everybody else, we will look at this, right? Here we have a 30-degree angle. And we have, our opposite is going to be x, and this side over here is going to be x squared root of 3. You see that? Now your cotangent is going to be adjacent over opposite, which is going to be x squared root of 3 over x, which is going to be just square root of 3, and that's not it. But if we look at our 60-degree angle over here, what's our opposite and adjacent of our 60-degree angle? Well, there's your adjacent of 60, right? Here's your opposite. So what you have here is you have x over x squared root of 3. X is canceled, so what you have left is 1 over square root of 3. And this also gets into the definition of sine and cosine, because the sine of this angle is going to be, okay, that's 2x, right? The sine is going to be x over 2x, which is 1/2, right? Well, the meaning of cosine means that it's the sine of a complement. So that's what the definition of cosine is, the sine of the complement, or the complement of sine. And what is the complement of 30? 60, right? And what is the sine of 60? Well, it's going to be it's going to be this over this, which is square root of 3 over 2. So the sine of the one is the cosine of the other, essentially, is what it amounts to. So theta is equal to 60 degrees, or pi over 3 radians. Okay? Let's look at this. Let's look at 44. So Carmen, you want to do 44 instead? Yeah, Carmen will do 44. Gave Carmen a hard one. And what does the very last part of the song say? R, cosine is x, and our sine is y. So what it is, you look at that unit circle, and those x coordinates are your cosine. The y coordinates are your sine. So what do we have, Carmen? Where do we see square root of 2 over 2? Oh, you're looking at c squared 2 terms. Yeah, so we get theta equals 45 degrees, or pi over 4 radians. Okay, questions about that? Okay, next one, secant theta equals 2. I'll call on somebody for this one shortly. All right. Theta is equal to,
So I'll just tell you what I did, or I was thinking.
well, go ahead.
So I put it'd be 1 over 2 after you change it to cosine.
So you're saying cosine theta equals 1/2?
But when I'm looking at our chart, 60 degrees and 30 degrees, like, it has 1/2 on 60 and 30. So I didn't know which one to use.
Okay, that's a good comment. Okay, what it is, our cosine is x and our sine is y. So all those things,
Oh,
they're coordinate pairs. They're xy coordinate pairs. So you look for the coordinate pair whose x value is 1/2.
so that'd be 60 degrees.
Yes, 60 degrees.
And then pi over 3 radians.
Which is pi over 3 radians. And I'm glad you asked that question, because would you be surprised if I told you that someone in 5th period had the same question? No, you wouldn't be surprised. And I think it was Elizabeth. Okay? Okay, next. Here, let's get one of our remaining suspects. Kaylee, all right, Kaylee, all right. All right. What do you think, Kaylee?
So what I got to that
You didn't get an answer? Yeah, let me look at it here. No, it's not an acute angle, okay? What you gotta look for, it's gonna be adjacent over. So what you have, cosine divided by sine, and you only have 3 choices, is equal to 1. And that's your answer. Am I speaking Chinese? Cosine divided by sine is equal to 1. Is that it? Good. All right, guys, what you're looking for is now tangent theta is opposite over adjacent, right?
Yeah.
And so what you have is, what is cotangent equal to?
Adjacent or opposite.
Adjacent over opposite. Okay? And so what you have is, you look for what this is going to be. This is going to be equal to cosine over sine. That's what that's going to be. Where do you see a cosine over sine equal to 1? 45 degrees. And what it is, it's because you have square root of 2 over 2 over square root of 2 over 2 is equal to 1. So that's how you get that. Does that make sense to you now? A little bit, maybe? Kind of, sort of? Okay. So now we're to tangent theta equals square root of 3 over 3. And before I spin on this, I'm going to tell you that this could also be written as 1 over square root of 3 is another way you could write it. Okay? Stars don't tear off very neatly. Okay. All right, next we have three candidates here. Okay, we got Hannah on this baby. Okay, what'd you get for this one? 30 degrees? Or 5 or 6 radians. So let's test it here. If we draw a special right triangle, and that's 30 degrees, then this side over here is going to be x. This one here is going to be x square root of 3. And your tangent is going to be opposite over adjacent, or x over x square root of 3. And what does that simplify to? 1 over square root of 3, which is the same as square root of 3 over 3. So yeah, that's right. Is that how you did it? Kind of. Okay, and we have Okay, number, this one here shouldn't be as hard as some of the other ones we looked at recently. Is it going to be Kayla or Will? It's going to be Kayla. All right. What'd you get for this one, Kayla?
30 degrees?
Okay. Or
60.
60 degrees?
I'm not sure, it's one of the two.
Okay, let's look at that. You say you think 60 or 30?
30.
I'll put down 60.
So it's 60.
Let's talk about this, okay? The x's are 1 square root of 3 over 2 horizontal. They must be square root of 2 over 2, and next are 1 half and 0. It's actually 30. 0. X's are 1 square root of 3 over 2. 6. You were right. You were right. 30.
I was right, first one?
You were right for yep.
What was the first one I did myself?
Yeah. So that's going to be pi over 6 radians, right? Now, we're just about out of class time, so we're just going to start this set here. So we'll probably tomorrow finish this and go into, but I want to just start on this today. Is, do you know how to find the, Will, do you know how to solve for this right here? See if you can do it. And I'll give Kayla recognition, and then you will... What do you think? It's going to be an equation with sine, cosine, tangent.
Yeah, I know that.
What are you doing in heaven? Oh, yeah, what are you doing? This season, that's what we're talking
Which one is this going to be, sine, cosine, or tangent?
I can't tell sine.
Sine? Okay, let's see.
Is it? No.
Sine, let's look at sine. So sine of 34 degrees is equal to what? Opposite, what's our opposite side? What's our opposite of 34? 15, right? Over hypotenuse, what's our hypotenuse? X. So now if we solve for x, what's x going to be? That's going to be 15 over sine of 34 degrees. Is that what you got, Will?
Honestly, don't know. Sure, that's what I got.
Yeah, so x,
Yeah.
cross multiply the x, then divide by sine 34. See that? Yeah, so you get 26 point something. Yeah, so you can so this is one where you can actually put this in a calculator, and if you're in degrees, you can get it like numerical answer. So sine, so 15, but I'm in radians, right? What do I need to do this? Degrees, right?
So
So
what's the difference between the two?
what's the difference between degrees and radians?
I mean, like, on the calculator.
Well, you know how to,
Measures the degrees and what's the radians.
they're different units of angle measure, right? One radian is approximately how many degrees? Anybody remember?
One radian, like 3, gosh, I don't know. Wasn't it 60?
3.14.
It'll be a little less than 60, yeah, it'll be like 57 point something.
Yeah.
So 15 divided by sine 34. You used to remember that, but you've forgotten it since then. That's all right. So 26.824. 26.824. We're going to work on this more tomorrow. And we're going to start on chapter 4.3 tomorrow probably. So just hold on your paper. We'll resume tomorrow. How's that?
Sounds good.
All right, thank you.